All right, IBAASL2. We finally made it through derivatives. Well, for now. Now we're going to focus on statistics, which is going to be a nice breath of fresh air because it's very different. First thing we're going to focus on today is how to take a raw data set that's just been ordered and turn it into something called a frequency table. So frequency is how often a data point occurs. So when you look at this group of numbers right here, I see that they go from 0 all the way up to 10, and that there's a lot of repeats in there. This is a very sort of uncomfortable way to look at the data. It's not easy to work with because it's so long and there's so many repeats and things. So to construct a frequency table, what we're going to do is take the scores. So the scores are just the raw data, each type. So these are the scores. And I see that they go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they hit every single number, and none of it skipped. So we're going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, some books use like a tally mark where you can keep a little tally column here, and then you go through and see that there's like 1 0, and then there's 2 1s, and there's 3 2s, and you could just keep track like this. I don't think this is absolutely necessary, so I'm not going to do this, but know that you could, just because it's the easiest way to make a mistake with this is just to miss a number, and then it's kind of a bummer because all your data is going to be off. So we're just going to jump straight to the F column. The F stands for frequency. Frequency is how often those numbers occur. So in the data set, I see 1 0, which means we're just going to put a 1 right here. I see 2 1s, which means we're going to put a 2 right here. And then there's 3 2s and 2 3s. There's 3 4s, 5 5s. Ooh, that one matches up. Fun. There's 4 6s, 6 7s, 4 8s, 1 9, and 1 10. So this is a frequency table. There's different types of frequency tables that we'll go into, but this is just your basic one. You'd want to organize your data into a frequency table, like I said, when there's lots of repeats of numbers. You could take this frequency table and turn it into a bar chart. So a bar chart, you guys have probably seen these with data presentations. You would put your scores along the bottom. So we go from 0 to 10, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the side, you would put your frequency. The tallest frequency in my table, the biggest number here, I think is 6. So I don't need to get above 6. So we'll go 1, 2, 3, 4, 5, 6. Then you would just take, let's do a different color just for funsies, each of these scores and then make the bar as high as the frequency is. So for zeros, there was 1 frequency, so that means you would put a vertical bar here, that on 0 there was 1, and then on 1 there was 2, and then on 2 there was 3, 3 there was 2, And then on 4, there was 3. Uh, 5, there was 5. Notice that these bars are not touching each other. That would mean that the data is sort of continuous and there's things in between. But this data is just like whole numbers. It's discrete is another way to say that. So yeah, the bars should not touch each other. They should just they should have white space in between. It's discrete data. 7, there's 6 of them. Let's see. Oh, it's the tallest one. Man, I really should have spaced these out more. These are some skinny bars. 8 is 4. Skinny bars is also my MC name. 9 is 1. And 10 is 1. So this is called a bar chart. Next up, we're going to talk about bar charts versus histograms. So notice I came up with 2 examples. These are completely separate. It's not the same data set. It's just an example of a bar chart on the left and a histogram on the right. Bar chart, we just constructed one of those. You got these vertical columns. There's white space in between. They don't touch each other. It's mainly for discrete data. Histograms are more for, I guess we would say, interval data. Another thing to talk about here is that this histogram is continuous. Notice that there is no space in between these bars. Like this goes all the way up to the next interval and then goes here. So like it's continuous. There's no gaps in it. As opposed to our bar chart, like, you know, if we were to look at this guy and go, okay, you know, how many 2.5s is there? Well, it's like, well, there are no 2.5s. Like, it's only whole numbers. It's 1, 2, 3, 4, 5, 6. As opposed to over here, let's use another highlighter. What this section means is that between 1 and 2 in the data, there were 5 data pieces because this goes over to 5. So this means 5 data pieces from 0, or no, not 0, from 1, that's the beginning of the interval, from 1 up to and including 2, not T. Come on, Jolly. So there's a lot of decimals that could be in there. I don't know what the raw data is. I just know that there could be a lot, you know, that there's 5 numbers between 1 and 2. Including 2, not including 1. That's another thing to talk about, is that this book makes a distinction about the lower part not being included and the upper part is included. Now, I have 3 histograms for you here, and you can describe the shape of these distributions. First of all, let's go straight to the one in the middle. This is called a normal distribution. Please notice that it is symmetrical. Distribution, there we go. Symmetrical meaning, like, if I was to split it right down the middle, that I could fold it in half, and this half, I don't like that highlighter, this half is going to match up with this half, mostly. As opposed to these other guys, they have a skew that's going on. So this one has a skew, and this one has a skew. Now, one of these is a negative skew, and one is a positive skew. And when I throw these up there for students, I'm like, okay, you guys, which one's got the positive skew? Most people go, this one, Jolly. This one's got the positive skew. But just like in mathematics, a lot of times your intuitive answer, what it actually is the exact opposite. So this one actually has negative skew. Here's how I remember that. The middle of this data, or like I guess the mean would be, or the median, sorry, not the mean, would be somewhere around here, which means that this side is way more stretched out than this side. Like, this side is smaller and this side is bigger. This is the negative side. So it's got a negative stretch going on the negative side, so it's negative skew. Same thing with this guy over here. don't know why these are all guys. The same thing with this dude, person graph. That the positive side is stretched out. So we say that this is positively skewed. That's it for skew. All right, an example. A group of teachers were asked how much time they spend eating lunch in minutes. And this is the saddest data I've ever seen in my life. There's 4 teachers that are spending 1 minute eating lunch. And then there's 2 teachers that are spending 2 minutes. And then the most any teacher is spending on lunch is 16 minutes. Oh my gosh. You guys, first we're going to construct a frequency table with this data. Now, they're telling us in the direction that we're going to use classes. Classes means that the data is going to be split up into intervals. The reason that they want to use class intervals with this data is that if you look at it, yes, there's repeats, but it's very spread out. There's a lot of numbers. Like if we were to do a frequency table, it would be very tall, very long, because you'd have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data pieces, which in general, frequency tables you want to have them kind of nice, like, 4 to 9 intervals, or, 4 to 9 rows. So they're telling us we're going to split this up into intervals of 0 to 4, 4 to 8, and then the next one would be 8 to 12, and then 12 to 16. So let's put these intervals in here. 0 to 4, 4 to 8, 8 to 12, 1, 2, 3, 4. Oh, I added an extra one on accident. 12 to 16. And that should cover all of the data. Now, if you go through that data and you start crossing off, like, from 0 to 4, if I look just here, not including 0, but there's no zeros, and all the way up to 4, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that's our first frequency, is that there are 8 numbers between 0 and 4. Then if you count up all the numbers from 4 to 8, there are 12 of them. Now, you're not including 4. So this guy is in the bottom interval, and then, like, this, because there's no or equal to, means you don't include 4s in there. So there's 12 numbers from 5 all the way up to 8. So that would be all of these guys. 12 of them. The next interval, there's 10, and then the last interval, there's 7. If you were to add all these up, you would get the total number of data for the problem. Oh, I thought that was given in the directions. Yeah. Sorry, it said there was 37 teachers, but if you add it all up, that means there was 37 teachers in the study. If you add all of the frequencies together, you'll get 37. The last part of this is that we're going to construct a histogram with this data. So when I look at our data here, I see that it goes from 0 up to 16, and we're going to split it up into 4 intervals. So here we'll go frequency on this side and intervals on this side. So I'm just going to split it up like, 0, 4, 8, 12, 16. So those are your scores. Then the frequencies don't get above 12. So let's do 4. Yeah, 4. Sorry, I'm just deciding how much blocks should be. 4, 8. No, I don't like that. Let's say that they go up by... I don't know how to make this not weird. Okay, maybe we can fit it all. So, 3, 6, 9, and we'll go all the way up to the top for 12. So this is your frequency. Now, from 0 to 4, there were 8 pieces of data. So I'm going to have to go 6, 7, 8, all the way up to here, and then connect this down. So there's the first interval. That between 0 and 4, there were 8 pieces of data. Then from 4 to 8, there was 12 pieces of data. So we go up to 12. Then from 8 to 12, there was 10 pieces of data. And then the last one, there was 7, from 12 to 16. And there's the histogram. Oh, hey, pop quiz, hotshot. What kind of skew does this histogram have? Let's see. I mean, the middle median type scores maybe around here. So I would say that has a little bit of positive skew. So little. Fine, I'll spell out little. Yeah. All right, you guys, that's it. Good luck with your homework. Ask me questions in class if you are struggling.